Hi, my name is Varun, and today I'm going to be talking about my EE267 final project, Surround.Pi, a framework for immersive spatial audio simulation and education. I highly recommend wearing headphones with left and right channel separation for the demo. I was inspired by homework 2 in this class where we looked at different forms of shading, and I wondered if it would be possible to build a similar environment for spatial audio. I ended up thinking of these analogs. Instead of flat shading, we could try a basic audio model. Instead of Phong shading, we could try something that's better than a basic audio model, or the head-related transfer function. And finally, instead of ambient shading, we could experiment with encoding and decoding ambisonics. These are the classes that I ended up coming up with. And for example, like a track is a song. The HRTF speaker uses the head-related transfer function response for localization and inherits from a basic speaker. And finally, we have ambisonic speakers and also a soundstage where you can put everything, all these different speakers on and see what it looks like and try different audios. So start off by looking at basic stereophonic sound audio. Basically, if there's a sound that's in front of you, maybe a little bit to the right, your left ear is going to hear it slightly afterwards. So being able to capture that difference in time. And some important constants were there's about 0.2 meters between your ears, and the speed of sound in air is 340 meters per second. Let's look at a quick demo. So we have our basic demo right here. We're pulling up a bark onto our soundstage and placing it to the right of your head. And that's where the sound is coming from. Awesome. So you probably heard it a little bit to the right, but it's pretty hard to tell. So it's a very simple model. Then I decided to look at the head-related transfer function audio model using the HRTF measurements of a Kemar dummy head microphone from MIT. There's this huge data set that provides impulse responses from different angles, both azimuth and elevation. And it gives you different impulse responses from sort of 0 degrees all the way to 180 degrees. And if you want something on this side, you flip the right and left channel due to symmetry. And so this is an example HRIR, or head-related impulse response function at negative 110 degrees. So going from this way onto the other side, and it's a result of a flip. So we can try a demo as well. Here we're pulling up 2 tracks, a roar and a bell, and we're setting them to be in 2 different locations. And let's see if you can tell that they're coming from different places. As you can see, there's one slightly in the front and to the right, and one slightly to the back and to the left. Awesome. And then finally, I looked into ambisonics for surround sound, and really is just about implementing the decoding and encoding of ambisonics, since we don't really know the true directional information, which you would usually get through a special microphone. And this is all included in my final demo, where we continue with our same soundstage, add a couple of tracks, and add ambisonic speakers with a flute sound. We also add 2 basic speakers and 2 HRTF speakers. Let's take a look at what this looks like. So this is what our layout is. As you can see the ambisonic speakers as well as the others. Yeah, so that's what I worked on for my final project. I think it's a really cool experience, especially if someone has taken this class and they want to learn more about spatial sound to try and build something like this. And I learned so much. Thank you for listening.